Hey guys, once again, welcome to another tutorial. In this case, we will be learning how to actually land a spaceship with Thruster's tools. Everything from the effects, to the layout, to the compositing. Everything will be handled here. So stay tuned and watch the full tutorial. Also, don't forget that there is a discount price for the spaceship down below in the description. So beware, try if you want the full file to get also the spaceship. Otherwise, we will have a proxy for the delivered files. See ya. Guys, do you want to join a really nice server? We have tons of different channels. We have effects, modeling, loop dev, compositing. We will have resources for every type of discipline. I also have a Patreon page where you can support me. I have every single file, I have polls, I have even some tools, guidance. So if you are interested, you may have a look. Thank you.
Okay guys, so let's go straight to the point. And in this case, we need to first create the ship with the lights. So this is how it looks rendered with the lights on. Hello guys, so we have the scene, and the first thing we got to do is to make this look nice with some lights, because this asset doesn't have any light. As you can see, if I go to CPU, there's no lights whatsoever. So firstly, even before adding lights, let's do a small and fast rig. I left in this file a way to actually switch, if you have the ship or not, between the proxy and the final version. So let's hop in. And the only thing that we have to keep in mind here is the skeleton and the unpacked version. So let's go into here and let's see what we have. This is the unpacked version of the ship. As we can see, we do have some places to play with these packed objects. What I did is to get this rig into a sub modify. This is the file, and this is the sub modify. And when I unpack the USD, this becomes a packed USD with a name and a path. So we need to create the skeleton. As you can see, the skeleton is quite simple. We just press enter and we can add bones to it. These bones are all named, as you can see, middle base, then we have middle front leg, we have middle front, and so forth. So once that we make this rig, which is a rough rig, as you can see, we need to modify it a little bit. So what I did is to actually the points 0, 2, and 4, which are 0, 2, and 4, set them to the middle, because they're going to be there. And then I'm going to be creating this skeleton, so I can in fact recreate some parameters. And just plug it in here, and then you mirror it. And what you do is to mirror everything that has the left, you will mirror it and use right. And these are the groups which I'm using. If I delete the groups, it doesn't work. So as you can see, we now have everything that we need. Or we need to capture. The way of capturing is super simple. We select a joint. We have the left leg, for example, and then we select the left leg. In this case, sorry, the left wing. We selected the left wing. Click and enter. And you do this for every single one of these guys. Right, middle base, for example, for the middle base, I selected all of these, which is very nice. Then what you need to do is just use a bone deform, and with the rig pose, animate these bones, right? So you can roughly move the ship here, move the wings, because everything is controlled via the pivot. What I did here, guys, you have to take a look. I tried to be as center as possible to this axis point in every way I could. And I think to keep in mind, let's go to the rest position. In the rest position right here, okay, I could probably be using another yeah, because the first frame, this is not what I wanted. But anyways, for the first frame, what I could be using is everything in 0, and have a look how these are kind of aligned. What I did is to actually rotate some pivots. Let me look for a pivot that I edited. For example, this one, which is in the front leg. Let's look for the front leg. Oh, is that one, which I never use, but let's use the right leg. Okay, so once that we have everything set up, you will see that if we make an animation, we will have the rig if we press enter, and we can start playing around with these guys. So the only thing that changed is that I, for example, don't want to use all the axes. In this case, I only want to use the x-axis. So what I did, not to get confused, is to lock the parameter. You can lock it with right click, unlock. For example, if you click here, you will have all the animation of the spaceship flying right here. And I usually try to work with the animation editor. You press split left and right, you go to the scene view, and you make this a little bit bigger. And if you press H, you will see all the animation curves. And you can see if I press something, this will move, and so forth. I usually try to make this as soft as possible. So I don't want to have something like this, for instance, because the movement might become a little bit harsh from one moment to another. Of course, this is not an animation tutorial, but in this case, you have the rig created, everything parented, and with the boundary form, you will use the rig pose to make all your adjustments. Once we have this, what I created is, let's close this. We have just this output where I splitted the left thruster and I left everything else separated. And I did a small transform at the end. You will see why when I have the ground, but basically I just wanted to tilt this. This is a hack, you should have it in the rig, but I'm not a rigger artist nor animator, so I tried just to fix it with the simple placing the pivot right where it belongs and just tilting it, boom, and then everything matches quite nicely. So then I also added a trail and I saved this ship, which is the proxy, just so you can guys have the animation. So let's go into here and let's go one frame backwards. So we have the ship. Let's go to the first frame. In the first frame, this is on the T-pose because I have a switch right here where it changes to the packed RVD. Just on the frame one because I want to have this on a rest position. So what I did here is to create a couple of lights. Let's watch this and let's also watch all these lights right here. So you will see that if, for example, if I go and press enter, I can see this light. Nice. So I place this right here. You'll see, hey, but then there is an animation going on. So how can you manage to link them? So there is a nice, cool node, which is parent constraint. Once you place all the lights with, for example, I am using light, blue light, LT, and the rights are just the same, but RT, and LT. With the parent constraint, what I'm doing is selecting everything that's inside LT and parenting it to this fetch, which in fact this fetch is just linking to the rig. It's just rig. And what I'm doing is just to parent one object, in this case, the right. Well, this should be right, but anyways, it just works. I just mislabeled them. So when this moves, you will see that it follows the animation. And I have everything set up for each of my lights in order for them to follow. You will see if I go into CPU, everything is following the ship and the objects which I want them to be following. Each of the lights have a different attribute. In this case, for example, the front lights, which are these ones, have a cone light. As you can see, there is like a cone, because in the options you will see there is a lot of, this is, for example, is referenced because I only wanted it once. In the way to reference, Ctrl Shift Alt and drag, and now it's referenced. If you go into shaping, I changed this to spotlight, and I can increase this or decrease it. You will see. You can also increase the softness or decrease it. to make it sharper or not. The same for the backlight, which are this one. You will only see them after if there is something being reflected here. And there are some lights here. These are the top lights. The top light, again, this can be increased or decreased. And they're just agreed on top of the thrusters. Of course, I also have these, which were placed before. And there are some side lights right here, which are just lighting forwards. And you can see, in this case, there is no backlight. I did create something for the spaceship. If this change, it's going to load at any moment. So this is how you create the light setup and the rig setup. Once we go further, for example, in this step, we will see that we have some thrusters going on here. And this is a cool trick, which I did. There is like a little hack on the material. But first, let's create the actual source. So this is super easy. I created a circle. I resampled the circle so we have more points. I added a mask noise. Let me show you how this looks. It's just a noise flowing in time. Then I'm copying this to make it smaller. So we have different circles. Adding a connectivity with a class attribute. So each one of these guys is actually one different class. Then adding different colors. I'm just creating the attribute name called color, the primitive, which is a random one. We can show this. Let me see. Color. There we go. And we are also ramping the vector CD to the color. So I can control how these gradients work with each other. I'm also adding IDs, and I'm adding a point in the middle and calculating the distance. Which is this one. You can see this should be 0 and this should be 1. All around is 1 because the radius is 1. And I'm adding noise. So I can control how much the noise moves. In this case, I'm multiplying 2.5 by this animation, which is linked somewhere else. It's linked to another tool I have of the thruster being adding force or not, plus a minimum, because I always want this to be like a minimum, as you can see here. So this is what we get. We can, of course, control the shape where we want, exactly as we want. And the code is just simple this. The position Y is adding to a multiplier, which is this one right here, with a mask, which is the mask that we have right here, and to a distance, which is the distance we have here. Then we merge both of these guys. We promote the color and the CD from primitive to point. We add all of this together. So basically we are just deleting the geometry. We're adding this back again with the ID. I could have used one, I don't know why I used to, but this is the by attribute ID, because every point has its like brother. Then I'm resampling this, I'm remapping some attributes, like for example the P scale, which is here. I'm just remapping. Let's see the P scale. This is the P scale. Okay, the P scale perhaps is not well remapped. Oh, because it's -2. I don't remember having the -2, but okay. Then another sample with the velocity and the curve view. Let's see if we can see it. I think we should add, yeah. So if we added this, you can see that there is a velocity going from downwards to upwards, and there is a curve view variable, which is this one. So we can control the edges. We are going to go for each one of these class, and we're going to be, in this case, doing, hey, find this guy. So in the first input right here, which I'm connecting this to the first one, in the point, the class is the variable class equals to class on this one. If it's not, then remove. So I'm just keeping from all of these cables the one which matches the iteration. And I'm calculating the distance again, because I want to know far away are you from the distance? And you can see I can create some nice threshold, and I can remap this after fact, so I can calculate the maximum, which in this case the maximum is being controlled by the multiplication of this guy right here, so it's always normalized, and I can control the output. Right now what I'm seeing is the distance, and their name is being okay, so the original name is called edge, which is this one. So let's watch the edge. Let's see, we have it here edge. So in this case this is going from 0 to 5. Let's have this, so we can control how this ramp works from the edge. We're going to be doing this for each one of them to create this edge. This is already starting to being a little bit slow, but it works. Then CD is going to be multiplied by the edge, so you can see we have the color, and on the edges it's going to be a little bit brighter. We're going to be replicating this with the sphere and the attributes, and we are going to be copying everything. And you can see we have the velocities as usual, and we're going to be bending this. The bend is going to have a twist, it's going to have a bend and a taper, and the length is going to be equals to the noise multiplier, which is equals to the height. And we can control how this looks, and also the vectors will be deformed. Okay, they should be deformed. Let's see, I can't really tell. Are they being deformed? I can't really tell. Okay, I think they are not being deformed, but it doesn't really matter that much because I'm not using motion blur for my velocity output, I think. Yeah, I'm using this here. Yeah, this velocity should be deformed, but that's actually easy to solve. You should probably just be using a rest position. Now, what I would be using is basically just a point deform, grabbing this one, grabbing this one, grabbing this one. Also, on top of that, we have the file cache where we're going to be saving the flames to the job inside the cache. And we have a noise, and the noise changes right here. Sorry, it changes right here, where I'm using this offset. So each one of these variants, as you can see, when I calculate the static, will be a little bit different. So we download from wedge. As you can see, all the variants are a little bit different from each other. They're going to be loading. This is called a wedging system, where you create a wedge and you create the amount of variants and you just plug it in. And when you do the wedges to merge, you create the specific wedge. Why? Because in this case I want to copy them to the respected points, so they can I can parent to the geometry, which I could have used the previous method, but I decided to use it this way. In order for this to work, we have the sources, which are these ones, which I'm just loading the specific wedge. I'm also going to be transforming this so it's facing upwards. Then I'm going to have this light instance. This light instance is just the middle point of the thrusters, which I'm going to be explaining right now. It's just getting the left source, and the left source is just, the thruster. I'm unpacking, creating a group on these 2 points, and blasting. That's all there is here. And the same for the other one, which is right there. And then I'm just blasting the points. Remember that these points do have intrinsic normals right here. They do have normals, so they will be pointing to the correct side. And finally, as you can see, I'm going to be iterating, getting all the metadata which I need, and the metadata is going to be bringing with the detail that you can see, grabbing the detail from this guy right here and getting the iteration, and basically it's just a number, and I'm iterating over the points right here to grab a different wedge, so I can control this for each, and each one of these guys is going to be different from each other, otherwise they will all be the same. And this is the same method, but making it manually. So how did I create this piece of mountain? Well, super easy with Heightfields. The trick is to make a height field roughly to the size of what you want, then adding a height field paint and make some blurs. And this is where I'm going to be creating like a noise on some specific area. As you can see, I'm using a mask invert to invert the mask right here. And we will see that this noise actually just moves on where there's no mask whatsoever, because the mask is just adding, it's making everything here. So I roughly had a camera set up right here, so I painted roughly what I wanted, right? So usually for these kind of setups, you want to divide your camera in two. One which is on the where the camera is looking at, which is this one, and the one is the actual geometry. Then I'm adding a little bit more noise pretty much everywhere inside this display, so I can have more detail. Then I'm distorting a little bit, as you can see, to create some more interesting shapes. I can change the element size. I'm resampling this, so it's a little bit higher resolution with this resolution scale by 2. I'm adding a little bit more noise, so we can have even more detail. I'm masking this by feature. I'm connecting everything that has this kind of slope, and I'm doing a terrace. The terrace is doing basically this kind of shapes, making it so it's a little bit more interesting. And then I'm grabbing this null, and this null is just the same height fill. I'm doing a bunch of noise. I'm creating a height fill distort by layer. As you can see, it's creating like these breaking points, and I'm blurring everything. So this is what I want to have right now. Then I want to have a little bit of erosion. If I go to a time shift, in this case, it's going to be just on the frame, I think it's frame 10, I don't remember, but it's calculating. It's on the frame 21, in fact. So the only thing that I did is just to change the max debris depth, so it's a little bit less. Change the factor of the erosion, so there's so it's not so much everywhere, and remove all the precipitation and add in a post smooth. The post smooth is just going to make so the debris is smooth, nothing else. Yeah, that's how it is. Everything is pretty much default. This is what I wanted. And I'm resampling this again, so it's double the resolution. I'm masking by feature everything that's on top, and I'm doing again, I'm replacing the mask right here. This is very cool. If you can replace the mask of the same height field, you can create a blur and you can create a noise, and just a noise where you want this noise to be. So with this height field, now you can in fact mess around a little bit where you want this to be broken. You can see that there are some places which are not really changing that much, and some others which are. In this case, I'm creating this like blocky setup, which is amazing. I really like how this turned out to be. This is distorted by layer. Remember, guys, if I remove this, there's no distortion. And then I'm clearing the mask. This is looking lovely. Adding a little bit of blur because some of the slopes were in fact too much. Sampling this and adding a new time shift with a new erosion. Remember, guys, you just need to have a little bit of fun with this. You don't need to copy everything. What you need to learn here is how to use the tool and not what settings I'm using in the tool. The resampling is making this being high resolution. This is a really high resolution mesh. You can see here, very nice, super nice, in fact. Perhaps too much. I'm resampling this, I'm like downscaling so I can make this usable because I don't really need that much. I'm converting the height field, and you will see I have 4 million polygons. In my experience, this is excessive. We are going to be using displays on maps later on. I'm saving this to disk. This is my original mesh. Then I can go here, grab it. I can also grab it here, right here. And what I'm doing is, the Pizola Frustrum. But this Pizola Frustrum it has an option. Remember, guys, this is a tool which I explained in many other videos. And creating this cone. Well, one of the options in the second output, let me look for it, right here, is to have a cone. The cone is basically just an extrusion of this little box with a cool trick called from NDC Geo, where you grab the camera. And what this is doing is just extruding this part. This is how it looks beforehand. And then it's mapping this to the camera. And there's pretty much nothing else going on here. But I'm using a trail. As you can see, I have 100 frames with an increment of 7. If I go to a time shift at the end, I can have everything where the camera is going. I can convert this to a BDB. I can group. And you can see nothing here and here is going to be shown, so I can blast it right away. So from the camera, I'm going to time shift this to the first frame. And I can calculate the distance from geometry. Just so I can have the distance variable right here. You can see if I go into points and I grab this, I have the distance from minimum, which is 8 meters, to maximum, which is almost 1 kilometer. I can map this to a range of 0 to 1. Let's see if I can watch it. There we go. This is the camera and the distance. And I can, well, I decided to use for another approach where I grab the line, I sort this and reverse the points, and I have 5 points, as you can see right here. These are the 5 points. And then I say, hey, that is equal to the points, and then I increase them to match the size of the terrain. And I transfer, look at this trick, I transfer the ID back to the actual ground. And you will see it creates some line. So I can know that, for example, this is going to be the first level of detail, the second, the third, the fourth, and the fifth. I promote this to primitives. So I'm going to be splitting this one, which is like 0. I don't want to do anything to this. I like the topology this already has. And then I'm going to be poly reducing this for each one of these IDs with these settings. I'm going to stiffen the boundaries. So the boundaries are going to mostly remain the same all the time. And I'm going to just keep the 10% of this. Everything else is going to be reduced. So I went from 2 million points to, at the end of the day, only 150,000. Because I only need the resolution here, which is what the camera is, right? I don't need anything else. Because you are not going to notice. I mean, you cannot really tell. Yeah, no, there is a little bit more detail here and there, but everything is going to have a displacement map at the end of the day, so who cares? And this is way faster. And at the end, the size is going to be by 3. This is something for the shader, which I didn't use at the end of the day, and this is how the mountain is created. So this terrain needs a couple of things. Firstly, I do have some rocks here, but before doing the rocks, we need to create the crystals. So how are these crystals being created? Because I have a bunch of crystals right here. Let's turn the rocks off. Let's turn this off again. Let's just keep the crystals. How these crystals are made. So they are made here in this crystal sub crate, which I should have used a sub network instead, but I don't know why I created a sub crate. So let's dive in. So all the setup is done here, where I'm grabbing this, which is what we had before, and drawing a curve roughly where I wanted this to be. Then I'm placing all of them to this 0, to the grid. I'm resampling this, and I'm resampling this again, so it's a little bit softer. And I'm scattering. I'm scattering based on, well, in this case I'm using a wedge. It doesn't really matter. This is just a seed. And I'm having this amount of points. I'm also transforming this a little bit so it adjusts to where I want, and I'm scattering points based on this seed again with the wedge, because I have the different wedges. I'm orienting this. Well, I can show you with the copy to points in just a moment. And this is what I have. Basically, this orient, I I could do something like this, but I just wanted to rotate a little bit on the y-axis. That's why everything is 0 except for the second one. And the orient is a fourth dimension. And this is the piskel. The piskel is very nice. I can add and randomize a little bit. But in fact, that the curve view is going to be determining my piskel, if I'm not mistaken. Yeah, the piskel is going to be a multiplier with just a simple line of code, simple remap, and then well, yeah, pretty much nothing else. There's a little bit of variation here, which I could have used right here, but I don't know, I didn't want to. And there is a simple box which is being match size, so it's right here, and it's offset a little bit downward, so it's actually inside the ground. Oops, and this is the copy the points. So this is my rough shape, and I'm blasting. I'm going to be a couple of selections. Did I blast it exactly? Yeah, I think I blasted some of these guys which I didn't like. I don't know why, I just blasted them. And I'm connecting this with the connectivity and creating the names. So now each one of these guys has a name, but all there is here is just the class with a, hey, what's your name? Your name is going to be equals to piece. Add an underscore, as you can see, if you go here and we press name, add an underscore and ito of the class. That's all there is. It's just this line of code. And this is creating the name variable, which I can change the name. And I'm just measuring fracture, and these are all the small ones which I'm not going to be using, so I'm going to be grabbing the other ones which are big. And this is the detail. So what's going on here? Firstly, I'm getting the height, the y-axis, the size is going to be saved on detail. This is the height of this box. I'm going to be matching this to the center, and I'm stashing the transform. I'm also, I don't know why I do of this. I think it's a mistake. Group 120. Yeah, this is probably a mistake. Then I'm blasting the 14th. All of them are the same, so every time this is going to be the top one. I'm scattering a bunch of points, changing the orientation. I'm adding some boxes. The same trick. Then I'm going to grab this guy and boolean this. So everything is going to be divided. I'm going to grab this BDB from polygons. I'm going to be converting this. I'm going to be bending this. So basically, I'm just using a tupper. The capture length is basically this calculation of the bounding box. So it's always matching the actual size of the object. And I can change a little bit of the settings. I just wanted to do a tupper. I'm doing a BDB from polygons again, and with a volume bop, I'm destroying this quite a lot. So what's going on inside this bop? Well, it's just I'm adding the position to the position of a noise with a terrain of a lot of roughness or not. Well, in this case, I think so. The more roughness there is, the harsher this is going to be looking. And I can create an amplitude of perhaps 40, which is going to be displacing a lot. My settings, and I'm adding more frequency on the y-axis, so less in fact, so this stretch upwards. If I have the same for everything, this is going to be a noise which is very normalized, but this one is stretch on the y-axis, which is exactly what I wanted. Then with a volume sample, I'm going to be just sampling the surface of my primitive name of my first input, which is this one right here. It's the same thing, and I'm outputting with the bind export the surface, and I'm converting this back again to polygons with a little bit of adaptivity. This is how it looks on the mesh, just keeping the details. And with this match size, which we had before, and we saved the transform. Look at this. Okay, I shouldn't have moved the match size. Oh, there we go. Okay, so this is the same, in fact. So this is the true copy. I thought it was I don't know why I thought it was a match size. Then basically just copying the xform from this variable, which I'm getting the xform from. I'm bending this before a little bit. As you can see, this is quite fun to work with. But the twist and the bend angle is going to be randomized between the iteration from -1 to 1 by 30. So these are, so it all depends on the iteration. Not all of them are going to be bent exactly the same. The capture length is going to be exactly the same. And with the spur parameter, I'm getting this detail of -1. The spur parameter is done by clicking here, adding spur parameter, and then you just drag in the metadata. And then that's why I'm using -1, because it's the first spur parameter. Then with the match size, I'm just placing this where it belonged initially, which is right here. I turn this box into this shape. If I do this for all of them and adding a little bit of bend again, this bend is placed in such a way that is basically like adding like a rotation. Because if, how can I explain it? All these boxes will be a little bit offsets here, but I wanted more. So what I did is to create like a line with this bend, and I bended all of them, especially the ones here. And you can see there are a lot of these guys stacked on top of each other. These are all packed. Why? Because I use, well, I basically just use wedges. You can see we have different types of wedges. All of them very nice. As you can see, it's changing the output because what I'm doing is to be changing the wedge number right here. And once that I have all of these guys together, I need to optimize them because this is very heavy to load. So we get the height right here, and for each one of these guys, I'm going to be unpacking them. I'm going to be setting the names, whatever. And I'm going to be just getting the large pieces with the measure fracture, which I forgot to explain beforehand how this works. But let me show you real quick. The measure fracture, it's calculating, in this case, the bounding box, which I'm getting on a vector all the bounding box information. I'm multiplying each one of the axes, and this is the bounding box size. And with a split, I'm saying, hey, is the volume less or is the area less, or in this case, is the bounding box less than a threshold? So everything that's smaller is going to go into the left axis. And look at all these small pieces, which I don't actually need. I have almost 80k polygons being deleted right here. So with a video from polygons, and again, remeshing this because otherwise we're going to have problems inside the mesh because everything is overlapped on top of each other. So I'm going to be having this. And there is a nice function inside this tool which I created, which is called the Pizola frustum, where I can in fact output a dot mask. You can see I didn't pull anything and I just kept the mask. What is this doing? Well, let me show you. Dot mask. This is creating a mask where the camera is facing, which is here, and where it's not. So with this information in mind, I can poly reduce everything which is looking from the camera and everything which is looking from outside using this method with a weight of 100. And you will see, let me go back again into the polygon. We have a lot of geometry here, and on the other side, we don't have pretty much anything. So I'm saving a lot of information from 800k to just a little bit of, I saved 2k. And at the beginning, this had almost 3 million. So I'm saving all of these guys together again on a single file cache. And I'm blasting the 0, the 1, the 2. Everything is super fast to read right now. And I'm moving them. I'm moving them here, I'm packing, reversing, because in the transform I just use negative values. I'm adding normals again, I'm packing again. I'm doing this for the background. I'm placing them in such a way that the composition is looping inside. And the first one, which is this, the only one which is not that changed, but it's still working pretty much rock solid. Okay, so you will see that there are tons of rocks scattered, and there is actually some sort of like breaking ground where these crystals will pop, as you can see. All of this is procedural. There's nothing dynamic here. And let's see how this is done. So let's hop in right here. And in order to see this better, we are linking this with the ground and roquitas. Also, I'm using the Solaris Look Dev visualizer, which is way better, I think, in my opinion. So let's dive in. This is, I think, my favorite chapter in this segment because it involves a lot of things which are very simple and cool. So let's begin. Firstly, we'll get these crystals. After we get these crystals, which this is the first one, the one we created for the foreground, we're going to do a couple of things. Firstly, let's create a new BDB. I'm just creating the BDB, reshaping, clipping this with the camera because I do not want to have everything. This is okay. And I'm going to time shift this to the last frame. I'm going to be converting this into polygon, going to be reversing this, going to be unpacking it. I don't know why I unpacked it. Let me check. Yeah, I think this is pretty much the same. So this is actually not needed. And I'm going to polyfill this part here. And again, BDB and convert. So I'm just filtering this geometry. Then we want to build this, which is the ground, in fact, as you can see. If you see from camera, this is it. This is the section we want to build. How did we create this? Well, we created it like so. We have the shapes, like the crystals, and I'm reshaping this a lot, getting our terrain, grouping with the volume, and blasting. So these two things are linked together. So having this in mind, I'm going to subtract my geometry, which is this one, from the ground to create some kind of holes. Also, I'm scattering something inside the crystals so I can then use it for another process for the distance. So let's begin on the next section. So we have this geometry, which is very nice. And we also have the same geometry, but without the hole in the middle, as you can see. And we're going to be promoting the UVs. Let me just show you to vertex, from points to vertex. Because you can see this has like an error on the edges and this does not. And if we transfer this, we will be fixing those errors a little bit. We're also going to be cleaning this in case there is something like an error. We're going to be poly reusing this even more. This is going to be far, so we don't need that amount of polygons. This is more than enough. Then we're going to be with the bold and the scatter crystals going to be calculating the distance from these points to the geometry. Also, I'm going to be creating like a gradient distance from 0 to 1. Let me just show you how this looks, which is something like that. I'm going to be scattering points based on this. Little points near the edges, then a little bit more. This is because I want bigger pieces on near the crystals and smaller the further away. If we boronize this, and then I'm going to be showing you the name attribute, which is not here. What is the name? Here. This is how it looks. So big pieces near the crystal, small at the outside edge. I'm going to be poly extruding this, just negative centimeters. Going to be reversing this, going to be creating the names, calculating the normal, so this is okay again. It doesn't matter in this case. Let me see if I can fix this. Camera. There we go. So it doesn't matter if we have these strange normals because this is going to be changing anyways. I'm going to be assembling this, and with the crystals SDF, I'm going to be reshaping this and grouping them. So we are only going to be getting this initial part. I'm going to be blasting these things out. Once we have this, we're going to be creating a couple more others. This is the Boolean object, and this is the bool. Both are the Boolean object. We're going to be calculating the distance again and remapping this. This remap is very interesting because it's going to be allowing us to calculate where we're going to be moving our object. And as you can see, I'm raising the ground with this function. The y position is multiplied by this value plus, multiplied by the distance. So I can go here and move around this. With a simple pointer form, we're going to be moving more or less this attribute with different types of fall-offs, right? This is where things get very nice. I'm going to have this and this together, and the one part which is point deform, we're only going to be calculating the rest position from the first point. As you can see, we're setting it here, and if the distance from the position of these points is less than the threshold, so the distance between position and the rest position is less than a threshold which I determine, we're going to be removing the pieces. So these pieces which are not moving like almost anything get deleted, and these are the transformed pieces. And then again, I'm going to be right here deleting the pieces which are already not going to be moving. So I'm just going to be saving this. What this is doing is saying, hey, find the name find the name here and match it with the names here. If there is no match, so it's 0, remove it. So if there are pieces here that they are not here, they're going to be removed. Over here, we're not going to just be unpacking this, nothing else. We're going to be adding a connectivity, basically. I'm going to iterate over the pieces. And per piece, we're going to do a small process. Firstly, we're going to be converting this, convert again to polygons, creating the value UV, and then distance from geometry from the following piece. Basically, I'm wrapping this only on the outside because so only on what's not outside. So because the ground already has UVs, and then I'm going to be transforming the UVs on the edge, so it pretty much matches the size of the pieces with this thing right here. So I'm just matching this. As you can see, they already have a similar space, which is what I needed. See, the size was very different. And then I'm grouping everything that's pointing up and blasting it, and then calculating the distance. And this is going to be basically a way to control our displacement settings for this mountain. As you can see, I'm calculating this mountain, creating like a noise based on the distance along the normal with this amplitude and these fractal settings. Then I'm going to be dividing this so we can have a better topology. This is key to transfer the UVs later on. From here, well, you cannot see anything, but this already has UVs again. And then I'm just transferring the name back again into the topology, into the pieces. And I'm doing this per piece on all the pieces. So let's see how it looks. Okay, so we are in the section which I think is the most important on this setup, the pyro simulation. So I created a couple of tools, these two, which I'm going to explain how this is done. But it will take care of pretty much everything. So let's dive in. So firstly, of course, we have our thrusters, which is unpacked, and I got these 2 points which start, and I blasted basically these primitives that already have this point attribute called start. It also has these, we can check the normals, it has these normals. All so far so good. I did the same for this one and for the right ones, where are them? Here. So we have both things. Also, we do have this light instance, which I saved, which is for something else. If I'm not mistaken, let me just double check. Yeah, it's for something else. So let's begin. What is this tool actually doing? And why is there so many things? Well, it's because I divided the simulation to high res and low res. So let's bring these tubes, and let's also bring the collider geometry. This is just a collider geometry I have. Let me show you with flat. Here it is. And I want this to be set to dark. So we have this ground, and we also have these discs which are moving. And we would like to actually be able to control how this is projecting to the ground. So this is what my tool creates. It creates, based on the ground, a tube whose points are getting displayed. Also, these points do have some velocities. Let me just show you the velocities real quick. So if I scale the vectors, we will be able to see some velocities, and as you can see, they do have a fall off from the very beginning. Let's go here. This also has a couple of attributes. It has the density, a final magnitude, a radius, and a velocity. So we can see all of them. We can see, for example, the radius. You can see let me see, the final magnitude. We can see the distance, I think. No, wait, which one was it? Oh, the density too. And the density, which is this one. Very nice, right? And this controls everything. Also, the thing in the middle is just a way for me to visualize how big is like the multiplication from the fall off. Everything outside this red is going to be fall off. So let's see how this tool works. We connected these two things. Remember, you need to have the group start. This is the only requirement. And in my case, this is working with a piece attribute called use the print path. You could use name, you could use whatever you want, because in this case you can see I do have a print path. It's just a name attribute, there's nothing else to it. This is because I need to actually control the rest position, and well, you are going to see one side, I think. I have this density animated, so you can see that once we are here, it's going to be just lowered. Also, if I go here, I can increase the radius of the start, or I can increase the radius of the end. I can increase the height. I mean, so how far this is going to be. I can remap some values. Look at how fast this is. So this is super easy to control. This is the noise value. Based on this value, we can control this noise or the pattern. We can change the pattern size, or we can offset it. Well, this is just a simple noise. All the values you need are here. They can be animated or not. What else? The post-process. Well, everything as usual, as a simple noise. On the velocity, we can also, if we go here, we can change a curl noise or not. We can add a conical or not. We can add velocity here or not. You can do a lot of things, and we can either reflect a lot based on the point and a tangent. And it's a reflect variable going to the right, or we can just increase the radial force, or do both things at the same time. We can control everything as we want, and we have some things. So you can see that there's in some places we do have some holes that you can see, for example, and this is because of the dot product. Basically, we can control in which segments I want. If they are pointing forwards, I want them to be masked or not. That's how it is. I could just turn everything off and everything would have a noise or not. And the distance, well, this is just based on how far from the point of this object, from these 2 points, how far it is, right? That's all it's doing there. We can calculate the minimum and the maximum. See, so I can actually control the fall off, which is minimum 30, maximum 150. That's what I solved here. And the radius, I can calculate how big this radius is. I still haven't figured out a way to actually do this proper as a visualizer, but as you can see, this visualizer kind of works. I mean, that's how it is. And the shape, you can see that I can, I don't remember what this was doing. Oh yes, this is for the amount of resolution on the edge of the circle, which in this case I don't think it's going to do pretty much anything visible, because this is control the P scale, and let's see the P scale. Oh, my bad. This is for the second output. There we go. So we can control the length of the thrusters, the resampling, the P scale. Of course, this has a P scale attribute. Let's see how this looks. We can control this to control the shape, the width, Everything is controllable. And we have velocity again, where we can control the like some kind of turbulence. This is good enough for I also exporting this with a pump, so we can have pump volume sources in the simulation. So all of these things are working in pairs. We have two different thrusters, so we have two different sources right here, and with the points we can do whatever we want. So let's visualize this. Ctrl+Shift left click is going to visualize this, and let's dive in. So what is going on here? We have the input, as you can see, and what we're doing is to time shift this, the frame start, whatever we have, and then this is just another frame start. I'm just copying it, and we're going to get extracting the transform matrix because these guys are linked together. So I believe we have an orient or a normal. What do we have here? Yes, we have a matrix right here. And then right here, what we are doing is from this on the time shift, we're going to promote these 2 points. We're going to split the group, and these are going to be like the meter of the thrusters too. We're going to extract the centroid so we can get the center, and we're going to transfer pretty much the same. In this case, it's going to be the prim path. You can also call it name or whatever you have on primitives. So I'm just having the centroid. So this is for a point. Oh my god, for a point which is moving, and it's going to be used everywhere. This is for to calculate the distance, the normal, everything, pretty much everything. And here, this is for the thrusters, because it depends on how many thrusters we have. We can create a line, and this pretty much has everything here. You see? So let's go here. This is a line. As you can see, we can control the length. We can resample as we want. We can calculate the p-scale, which is what I showed you before. It's just the curve equals to the p-scale, and the p-scale is remapped with a multiplier. And we're going to use a point replicate on spheres with 30 uniform scale and nothing else. I'm just copying the source attribute so we can have everything there. A point velocity, this is what I showed you before. And the velocity is going to be changed based on my tangent u. That is like the direction of the line, which is get here. This is one, and the curve is the p-scale, and also the velocity is going to be multiplied by a multiplier. That's about it. We are going to be changing this in subs, and one subs above, and the pump is equal to 1. So we have everything here, and this is all there is. On the other side, we do have the terrain, which is this one. This is the collider. We're getting the normals. We're also scattering a lot of points. This is necessary. We're calculating the dot product of from these points, which we got. It has a normal, remember guys? We're normalizing the normal 1 and the normal 2. This is the point 1 from here, and this is the normal from here. And we're calculating the dot from both of these guys together. We are also calculating the distance. We can see it here. Well, everything is red because it's not properly remapped. Oh, and this is not it. It is supposed to be the distance here. See? It's getting the closest point and visualizing this. And here we are just getting a tube, which is what we want, which is controlled outside. It's just the radius and whatever. This is how it looks. It's centered with a match size. It's pointing downwards, and we're transforming it so it's looking to the positive set. We're also scattering a lot of points, and with the point we can control which these points we can control everything, how these look, and it's just going to work. The same goes for this one, which is just an SDF. It's the same thing, pretty much, exactly the same thing, which I don't know why I have it duplicated, but it's the same. Oh yeah, I know, I have it duplicated because once it's going to be scattered, and I want to control this separately. And this is going to be turned into a density, and which is going to be copy and pasted. So both things are exactly the same, as you can see. But one is a volume and another one isn't. So with this, we're going to be calculating the radius from this one, which is the absolute of the clamp of the volume density from negative 99 to 0. How does this look? Because it sounds difficult. Radius, what is radius? It looks something like this. This is the radius. This is what we want. So I'm just clamping. Everything that's outside is going to be 0. Everything that's inside is going to be 1 with some, well, with some modifications. Because if I go here lower, or if I start to go negative, we can see that this is the circle we want. You can split everything whose radius is less than 0.01, which is everything outside, and we can calculate the distance from these points. This is why we got these points, and we're going to be calculating the mask, and the mask looks something like this. There we go. This is the mask. Lovely. We can have more points if we want it. The radius is going to be promoted to the maximum. So the radius is going to go to detail, and we can see it here, which is the maximum radius is 38. So this is basically going to be 38 if I'm not mistaken. Then we're going to get the radius max, and the radius is going to be remapped from whatever we have, from 0 to the maximum, to 0. I'm basically inverting the radius. So let's see radius, because beforehand we had this value from 0 to 38, and let's see, it was like this. So it was going to be looking something like this, to 38. But I don't want that. I want the opposite. So I just inverted it with this fit function. That's all the only thing I did. And the radius post. And basically having the possibility to control. This is what I showed you, that I can control the radius. But I cannot really use this one. Yeah, I think these parameters are not being used. Oh yes, they are being used. But it doesn't look like I need it. Yeah, I don't really need this because they are already normalized. So this is what's going on. The float Rm is going to be equals to the maximum radius maximum. And the radius is going to be a ramp, which is this is going to be the ramp. And I'm going to be fitting the actual radius data, which is 0 to whatever value we have here, from the minimum original distance, which is this one. This is not going to be used doing anything because I am already having this value. So I could actually just do 0, and this is exactly the same. But I used to have this being functional before. This had a purpose with, now it doesn't. And the minimum distance, which is going to be 0 to the maximum 1. But since I'm not going to be allowing the user to be doing this, I could just have a 0 and a 1 here. It's the same. Then the distance and the distance post, which looks a little bit complex, but it's actually very simple. So the dist post is basically, let's go and watch it. It's basically a multiplication between the distance and the dot product, as you can see. So I'm going to calculate the fall-off, which is this one, of what? Of the distance from the minimum to the maximum to a maximum and a minimum. Basically, I just inverted everything. I inverted it here. I could just have used the opposite. It's the same thing as the one before, I just inverted it. And then I'm going to be multiplying this by the ramp of the dot product that goes from -1 to 1 to 1 to 0. Which is just the ramp. I mean, what I'm doing outside is just a simple multiplication of two values. And the final magnitude, which we can see, is going to be equal to my final magnitude. I mean, it's going to be equal to my radius multiplied by my distant position, which is this one right here, which was used for the outer edge, and the other one. Having these two things already done, we're going to be able to do two things. Firstly, I can delete everything right here. And secondly, I can use the reflect. How does the reflect actually look? Well, the reflection is going to be saved, and is if I were to show you a drawing, the drawing would be that. If I have velocity going here, the reflection is going to be outputting there. That's the only thing. So I need a normal or a vector of any sort, which is the one coming from the point, which is that one. And I need another direction, which is every single point from this surface, right? It's going to go here, and most of them are going to go forwards. And also the velocity reflected on the y, I want to always be absolute, because in some cases it could just go downwards depending on the terrain. So everything going to be positive. I'm going to also calculate a velocity, which is already shown, and I'm going to be masking and adding a couple of things. First, I'm going to calculate the position of these guys here. Which are them? Well, firstly, I have this point, which is going to be right onto this terrain, and it looks like the point is here. And I also set the point. I'm going to add an add. I'm going to be measuring this and blasting. This is in case I want to do something else in the future, but I just blast the 0 point. And I have the center. And based on the center, I can calculate something. So I get the position data. And the velocity is going to be adding the normalize of the direction between the current position of the points to these points, which is going to create a vector that looks something like this. So all of these are going to go from the center. I'm going to be multiplying by something, so I can be multiplying by 2, and it would get just 2 times bigger. And I'm going to be adding their reflection. The reflection in this case would be a vector going that way, because I was going to do boom and then to the right. And also a multiplication of the reflex, so I can make this even bigger. And then going to be multiplying by the final magnitude, which is this mask on the points, all of this mask. That's all it is. And the density is going to be the final magnitude, which is the same, multiplied by a density. And then I'm going to do an attribute noise that, if I show you the density, is going to be multiplying these two guys together. And this, I'm going to be deleting everything but the values that we need. On the other side, this is just the visualizer. I get this cone for a color, and then it just removing everything whose radius is less than this or bigger than this. This is like the threshold. And then I'm just removing the points, and then I'm fusing them and connecting adjacent pieces, fusing, polypath, resample, removing all the attributes, polywire, and a color. This is a super simple visualization. I mean, I don't need anything else, and this is just for the visualization. If you want to see how this visualizer was done, well, you need to go into the node, and the guide geometry is going to be the visualizer, which is this one. I shouldn't have gone outside. And that's how the tool was done. Well, finally moving, let's show you how to do this collider. This is just the ground with an extrusion and this collision source, the pixel size of 6. Everything is merged together. And here is just the same one, but the same crystals, just getting the one on the front, BDB from polygons, converting this again, and we have two things, the polygons and the BDBs merged together. And finally, the spaceship unpacked, fused, trailed for the velocities and BDB from polygons with some point velocity and displacement, velocity and acceleration. So we have two things. So all of them combined again. You have these. So what did I do here? Well, basically, you can actually see that this spaceship goes through a really lengthy space. So I just didn't want to have everything all over the place. I want the back to be part of the low resolution and the front based on the high resolution. So in this case, for example, I deleted everything at the back. You can only see this at the back. The same is going on for the thrusters. Oh no, the thrusters are all over the place. So we have this at the back, which is just dilation and density, velocity, visible volumes, density. These settings with a nice shatter for the velocity, as you can see right here. I didn't need much else. You can of course connect like a pop solver here. If I were to do this again, I would have done this that way. And well, in this case, it's exactly the same, but this is a volume enable with these settings, and entity points and delete non-selected. And this is exactly the opposite. So if you go forwards, we can actually see that these points emerge once they get through this threshold. So we have these guys and this. We have the back and the front. The back, remember guys, is going to be equal to the low resolution. This is the low resolution. We're going to be showing this here. Thruster source A. This is what I need, 2 substeps, because I'm going to be using 2 substeps. And saving this to the heap, cache, load from disk, and saving this. So far, so good. Nothing different. But in this case, I want to have 2 different simulations, one for the left and one for the right. How is this done? Well, with wedges. With the last file cache, you can actually do a wedge, 2 wedges, one called thruster and one called division size. The one being, in this case, the first one, which is from camera, the one at the right, and I want the one at the right to have a different resolution than the one on the left. If we were to go here into this one, let's go to the first frame, you can see that the voxel size is different. Now that I think about it, I should have done the other way around, being this called 8 and this 5. It's okay, in the render looks just fine, regardless of this situation. So we can have both of these things. You need to save in background. It will go from left to right, and we can have both things being visible. As you can see, this is the right one, and it will just show once there is density. And both of these simulations are pretty much the same. I'm going to explain with this one, which is a little bit high resolution. In this case, this is the sparse object, which is pretty nice. And remember, guys, that we have some pump forces. Well, this is because I'm getting the thruster source B connected to the first input, and the source, this is exactly the same. But in this case, this is the pump and the B2 with the velocity. This is the thruster on the inside doing all that velocity addition, which is not the source on the ground, it's just some extra velocity. And the source, which is, well, the source on the ground, which has some velocity here, temperature, density. It is all nice, all very nice. And the collider. The collider is just the ground on the second input. It's just this, it's the collider. In this case, I did a really nice trick. Let's see if I can show you a couple of frames and show you what this is actually doing. So this is a wrangle which actually cuts the volume based on the camera. As you can see, we can make it bigger, we can make it smaller. Let's put this volume and divide it by 2, and let's go further into the simulation. Well, and as you can see, this is grabbing the camera. Imagine there is a cone going through the camera to the end, and we can actually offset this how far we want it outside the volume or how inside it we want. Then imagine there is a square going on from the camera outwards. So already having that into consideration, we can optimize the scene quite a lot. In this case, we grab the camera on these 2 NDC, and this is the camera, the offset cam 1, and we grab the position. The O is the offset, as we can see, and we said, hey, ndc.x, so the x-axis, is bigger than 0, or if ndc.x plus the offset, so plus this, is less than 0, or it is bigger than 1 if we subtract it. Basically, if this is outside here or outside here, or the same for the y position, so if it's outside here or outside here. Basically, everything that's not inside this view is going to be deleted, density equals to 0. The only thing that's going to be surviving is the source on the first frame, nothing else. And from here we did some block-based disturbance. You can see 8, 4, 2, and 1. All of them, or some of them with rotational force, except for the first one with different forces. The lower this size, the lower the strength. And on control, we are always using speed. This speed is coming from the solver. Now, on vortex confinement, we're going to be using 3, remap to confinement, and a little bit gas wind set to default. The only thing to get into consideration here is that the gravity didn't change, but on shape, we should have, oh yeah, I dubbed in here to actually go and see for myself how the speed, but I'm not going to be using anything of this. And on advanced, I'm going to be leading the BFECC and clamp advection, so it's better. The resize is going to have this padding modified. And what else? Anything on the sparse? Yeah, no, nothing. This is good enough. Oh, I'm calculating the speed film. And that's all there is actually here to the smoke simulation. So once we have all this, we can actually simulate both of these guys together a little bit different. So we have the first connection with the first simulation, which is going to be delivering something like this. It is the low res smoke from both sources at the same time. And I'm combining something. And in this case, we have 2 simulations. Remember, guys, this is an actual wedge we can create, and we can actually show you how this was done. The wedge is exactly the same node. I just copy and pasted it, and you will see that I can show you either the first one, which is this one, and the second one, which is this one, with a little bit resolution. I think I changed these after the fact because they look good. Yeah, they are inverted. This should be set to 5. This is how it should be done. So yeah, this is how it's supposed to look. This is the high res on the front and a little bit lower at the back. I'm going to be blasting the density because I want to have the velocity. I'm going to be resampling this to a voxel size of 3, and I'm going to be combining everything. This is what I will be using for other simulations. I'm going to be saving this, and this is how it actually looks. In fact, this is how it looks. All the velocities combined. And on the right side, well, this is a switch that I did. Basically, if I go into smoke or main, this is going to be set to 0, so it's the high resolution. Otherwise, this is going to be low resolution. This is especially good for when you don't want to visualize the smoke, but you want the shadows of the smoke. So, for example, if I wanted the ground, this would change to 1 with a take. Let's show you. I have a ground. It's probably going to be changing my viewport. That's why it's taking so long to load. As you can see, this automatically went to the second input. Basically, you all need to auto take and you just move the input that you want. Let's go back to main. So this is the same for the other one. And I'm also double checking and clipping this at the front. This is to be as maximum as possible on efficiency. Also, I'm combining all of them and be combining the velocity because it was getting some strange errors. This is supposed to not be necessary, but in my case, I did have some issues. Probably better off just to have one node here and another one here and call them separately. But I decided to fuse all the velocities into a single one. I don't know if this is the correct approach, but Karma was giving me some issues. And this is all the pyro. So now all the pieces are properly translated into high resolution meshes. And what we can do with this is the following. I'm going to be getting the ground pieces, getting the transformed, as you can see, so it's easier to iterate over. I'm going to be just transforming these pieces. So I'm just replacing the low resolution for the high resolution. So you can see, this is what I used to have back then. And I just transformed it to high resolution geometry. So this is already one of the first good tricks I learned. I'm deleting everything but the name. I don't need pretty much anything. And then saving this to disk on the job. Remember, you need to set the project. And on this side, what I'm creating are the different types of points I want for my scatter. As you can see, this is a very lovely scatter. So let's begin. I have this unpack. I'm transforming this. Is the low resolution. I'm subdividing them a lot. I think. Well, not quite, in fact. Oh, yes, I am. And on here, I'm also merging it with the rest of the pieces. And I'm masking by feature. What am I masking? Well, what I'm masking is based on the ambient occlusion. I want to get the ambient occlusion. So if I go into the mask, this is what I can see. Everything where this is hidden, there is ambient occlusion. I'm calculating the normal again. I'm like blurring it. Which now that I think about it, this is doing nothing. And then everything where it's pointing up, I'm going to be deleting. I mean, if the Y position is less than this, it's going to be deleted. So basically, I'm just deleting everything that's pointing downwards. As you can see, this one, for example. And I'm remapping. What I'm remapping? The mask. Basically, I just inverted it. Then I clean this. And then I'm removing everything based on the mask. If the mask is less than mask, which is this one, I'm going to be deleting way more or less. Then clean again. And on this side, I'm doing mask equals to 0 and I'm transferring. So this is going to be the scatter when I want to have everything near the pieces. I'm scattering all over the place. I'm adding a little bit of noise with this multiplication. And then I'm removing everything which I don't need with this simple function. I'm creating the piece scale, which is going to be equal to the mask multiplied by a value, which is this one. If I want to see the piece scale, this is how it will be looking. As you can see, there are pieces where it is very big and pieces where it's very low. This is how it changes with the masking, and I can control everything from here. And when the piece scale is less than this threshold, hence these rocks are going to be very small, I'm going to be removing all the points. So basically most of them. I'm also going to be randomizing the piece scale a little bit. So there is a little bit more noise and randomization to it. Look at this. Piece scale, the scale is going to be a 3, and I think, oh yeah, this should have been set to 1, but I'm going to leave it at 3 because it works as for. And the orient, I'm going to be creating a new orient. Let me show you how this looks. As you can see, everything is pointing upwards, but when I create the orient, this is all random. This is based on direction orientation. And what I'm doing here is calculating the density and removing based on, no, I'm calculating, like adding more piece scale based on the density. So look at what happens when I show you how it looks. So this is before and this is after. So basically the edges are going to get smoothed out and smaller rocks will be on the edges. And I can increase this, I can reduce it. I'm basically controlling the based on the radius and based on the max amount of points I want to calculate over the length. I'm going to be PC find over the first input, looking for the position, comparing it with the position of the point itself, using the radius and the max point, and it's going to be creating an array of points. And then the length of the points, which is this array, divided by the max amount of points, is going to be creating a value from 0 to 1, which I'm going to be using to multiply the value. Basically, the more points there are, the closer to 1. The less points there are, the closer to 0. So this is it. On the other side, it's pretty much the same. It's just a scatter with a noise on mask, which looks like this. I'm going to be removing based on the same trick, piece scale, and well, just calculating a little bit with these values. I'm randomizing the piece scale a little bit. Let me show you the piece scale. I'm just adding some randomizations, doing the same trick with the orient. But in this case, I did something a little bit different. So I do have these orients. Interesting. So I did create an orient which is only looking upwards, as you can see. And then with this orange right here, what I'm doing is like rotating them. Everything is pointing upwards, roughly in the same position, and then rotating all over the place so they get a little bit different. Finally, the same trick, exactly the same trick, combining both of them, so we have both the scenarios, and these are going to be the size f equal to the p scale. This is important because I'm then going to be using something for the display. Oh no, I think I didn't use it at the end of the day, but you can control the displacement of these rocks based on an attribute. The smaller the piece is, the smaller you want the displacement to be, otherwise it's going to be all messy. Moving on to this section, I'm going to be creating a couple of things. Firstly, I want to know the places where I do not need points. So what did I do? I got all these objects, turned them into BDB, reshaping them, combining them together. Also, this is basically just the ground extruded. So it's here. You cannot see it, but it's here. We convert this to a BDB and then group everything. So where there is like an occlusion, I'm just going to be removing those points because we do not need everything. So I went from 870,000 to just 100 less. And I'm going to be dividing this. Okay, so I'm going to be dividing all of them, which the speed scale is bigger than 0.5. I do not want these points to move because the rocks are big enough in my mind. And I'm going to be creating a box based on this volume. This volume is going to be controlling our rocks. This is the last frame, which is my velocity. I'm going to be grouping this based on these velocities. I'm going to be splitting them. This is not going to be simulated. This is not going to be simulated. And on this side, we are bringing in the volume box. Let me show you. This is the velocity. If I show you this, so you can see a little bit better. This is how it looks. These are all the velocities from my previous pyro simulation. This is simple. It's just the box with an ISO offset, scatter, and volume trail. Nothing else. I'm just getting the velocity, which is automatic. So, having this in mind, this is the only things which are going to be simulated. We can transfer the velocity. Let's see how this looks. No, let's see here the velocity. So you will see this velocity is getting transferred very nicely. And what I'm doing here is saying, hey, calculate the magnitude from the velocity, which is going to be from 0 to this value to 0 to 1, and active is going to be 0. So how does the magnitude look? It looks something like this. Where there is high velocity, the colors are going to be red. This is a nice way to visualize it, as you can see. Very cool. And in this solver, what we are going to be creating, which is starting on frame 1270, is a way to control which pieces get turned on or and off. So this is what we want to look is for the active, which is this one. As you can see, some points will get active and they will remain active all the time. Okay, so how is this done? Well, this is done with the following. Super easy. We're going to be transferring the active from the previous frame onto our input frame. And we're going to say, hey, the magnitude is equal to 1. Then active is going to be also 1. Basically, if we get past a certain threshold, we're going to just be activating those pieces. And we're going to be time shifting this to the final frame. Basically, it looks something like this. This is the final frame. And this is how it looks. All the pieces with the recording information. This is the ID equals to the ID PTNAM, so everything point has its own ID, and we're going to be splitting everything that's active from everything that's inactive on the right side. And here we are going to be just keeping track of the of these points, which are the active pieces. They're only that. So let's keep on going with this. We're almost done. We have a box, we have this set to UVs, subdivision, mountain, normal, and assemble. It is just a simple act object, and I'm setting this to the 0. Also, I'm going to get a box. I'm going to be match sizing this to the bottom. This is very important, and I'm going to be unwrapping this. I don't know why, and assemble this. Also, I'm going to have these points, and these points are from the to sim. I'm going to be having this P scale, the P scale 2. I'm going to be saving this. This is important for later. Remember, guys, I'm just having this name as this P scale as a name, and I'm saving the rest position. I'm going to be copying to point this, and this is what we're going to be simulating. This match size is important because it's going to be where this is sitting in the ground. It was important also to have the proper orientation so they are not clipping through the ground. So let's see where it is. Where is the ground? Here, here, and here. As you can see, they're all on top of the ground. So I'm going to remove everything at P scale to an ID, and I'm going to set this active to 0. Then I'm going to be grabbing the outer direction, which is the velocity, and I'm going to be clamping this basically with a fit. I'm going to be creating a ramp from 0 to 50, and I'm going to be clamping this because I don't want to have velocity all over the place all the time. You will see. Let's see on this place that the velocity is highly concentrated on some places only. This is because of the clamping. If there were no clamping, everything would have velocity, but I only want velocity where there is high velocity. Hence, everything else is going to be set to 0. This is a volume wrangle. There's nothing magical to it. Well, then I'm just doing the easy poly reduce, which is this one, because I'm preparing this for the collider of my RBD simulation. So we have this collider geometry, which is very low res, but we don't need anything else. This is pretty much okay. We also have the crystals, which this is how it looks. It's just okay. You don't have that many things going on. And perhaps it was an error to keep this unpacked, but anyways, it does work regardless on camera, but this should have been unpacked. And what else? Well, pretty much nothing else. I'm going to just be getting this simulation, saying, hey, active is equal to 0, and I'm transferring these guys based on the points which I did before. This is a cool trick, which is I got this thing which is all the active points, and I'm transferring this active attribute here, as you can see. And this is what we're going to be activating the piece on. So I have the rocks, I have the volume which is processed right here. I also have the collider, and also have the rig right here. And this is important, that keeps being packed because of the following. Let's jump into the simulation. So the trick of the simulation is the following. There is no constraints, it's only just smart activation. So we have the ground, which I'm getting here with the up input path number 2, which is just the ground and these crystals. This is concave, so it's using all the polygons. I'm getting, for my first contact geometry, a static object, and which is using the object transform. And the bullet data is to show the guided geometry. This is it. Everything is a box because I don't need anything but a box. This is perfect. I disable the sleeping and nothing else. And this is okay for what we need. The first frames, pretty much everything is going to be unactive. I also have the ship, which is the fourth context geometry, and it's an animated static object, which uses the object transform. And the density is very, very high in this case. And this is just going to be moving. Let me show you without the rocks so it's easier. It's going to be moving, and it's going to be treated as a, as a packed object, because it's way easier to do this packed object instead of having a static object as simulator. Way faster. Also, I'm going to be right here on the simulation. Let's just turn this on. In the simulation, I'm going to be advecting with volumes the following, without treating as wind and controlling, like animating from 0, I mean from 1 to this value 0.1. What I'm doing is basically everything that's the group not out, which I don't know why I did this, because every single group doesn't have out, but it doesn't really matter. It's going to be affecting the rocks. So basically these rocks are going to be moving. And this is very interesting. I'm going to be deleting everything that goes below this box. So if they touch the box, they get deleted. That's how it is. And on the solver, this is the core. I'm just getting the sims to be activated, which are all of these. And I'm transferring with a natural copy based on ID, and only this guy, which these are the rocks, the active point. So only on these rocks, because this is RBD pack, and everything that has RBD pack is going to be getting those values, and only then they're going to be moving. So they're going to be activating from the back to the front with a gravity of 20 negative, because they were flying all over the place and I wanted that. Right here, I didn't do pretty much anything else. No drag, no anything. Also, when I get this, I'm going to be getting the RBD objects. So I want to delete everything but the orient, but the p-scale 2, but the velocity, and but the ID. Here, I'm getting the quaternion, I'm getting the orient, which is basically the quaternion from the matrix 3, from the print intrinsic of the transformation on the print number. What this means is basically I'm just translating this transform matrix to an orient value, a vector orient. And the same for the pivot. The same happens for the pivot. I'm just transforming this pivot to this vector pivot. I'm adding this. As you can see, the way to know this is working is that beforehand everything was not working, the orientation. And the way to look at it is that if you were to connect this right here, where is this? Because this is baked, but when you get the transformation on the orient, it should be the same as these points. And you can see these are the points, and these are the rock. Also, the pivot changed. And the p-scale, I'm recovering what we used before. Right here, the p-scale is equal to the p-scale 2. Oh, this is duplicated, apparently. This is the group of the simulation. I got this beforehand. And these are the ones I want to ignore. I'm just actually deleting this. I'm merging both of them. I'm deleting with the preappend. I want to have all these values, as you can see. And I'm frustrating this based on the camera. I do not need anything that's outside the camera. Otherwise, I would have like almost double the amount of geometry. And before the frame 1070, I'm just saving the frame. And as you can see, let me just show you real quick how this looks. So this is, it starts. And as you can see, the spaceship goes and moves the points all over the place. This is from camera. Let's see if I can put some name or something so we can see it better. What can we see? 80. Okay. With 80 we can see it better. So here the camera, and it's moving. Let's look for the collider. There we go. And with the spaceship, this is even better. There we go. Excellent. So once we have all of this, we're going to be blasting what's simmed, what's not simmed, and we're going to be copying to points the simulation section, which are all these small rocks with different sizes and whatsoever. And on the other side, we're going to be getting the other part of the simulation, which is everything what's on the ground. This won't move whatsoever. So this is all of this section, which will divide into the sim rock, which is very important to be a packed primitive with the create point instancer from the copy to points and getting the simulation. And this is it's going to create an instance. Otherwise, the machine is going to explode. This is the simrock and this is the no simrock, which is just the rest of the simulations. Everything along with this creates the whole sim with all the simulations required.
So as for the materials, let's go into them. So let's begin with the crystals, which are extremely simple. Let me just disable this and let's dive in. Let's see how they look. I'm going to use CPUs just so it loads a little bit faster. So this is the crystal material without any type of light. We can add, for example, this HDRI real quick. Let's just plug it in here. So this is the crystal material. As this loads, let's dive in. And the crystal is just the following. It is the position. It is just the position multiplied. So so all the noises we are applying are very small. This is the noise we're using, and we are remapping everything to a 0 to 1 value, doing a ramp, going to these values, and then using transmission. I'm going to show you how it looks without transmission and without displacement. So it's a little bit faster. So without transmission, let's say we want to put everything into the base color. This is how it would be looking. As you can see, we can totally change one of these values to green, and you'll see it creates these kind of shapes. So this is the noise I'm using. As for the hex tree planner, what I'm doing is to actually have a displacement noise on the rocks. This is the scale, it's the size of 40, which is, I think, is quite cool. I mean, we are seeing this as blue because we have alpha. That's the only reason. And then finally, the other texture is a very similar one but smaller. I think it's even the same one, right? It's the same one but smaller. This will create, if we combine all of those, a really nice displacement, which looks something like this. This is nothing, and this will be with displacement. And as you can see, the texture is quite nice. It adds a little bit more detail, and it looks quite crystal-y like, right? So let's continue with other things. For instance, the mountain. But before doing the mountain, let me just disable the displacement. Let's load the mountain here. This is the mountain, and this is with the material applied if we use CPU. Very nice. We can also use GPU to make it even faster, but I'm going to stay with CPU as it is a little bit more responsive to me. So how was this texture done? Well, there are many things here going on. It looks quite cumbersome, but it's just a layering of different textures and noises. So let's use the standard surface. Let's just disable for the time being. Oh yeah, it's already disabled, the displacement. And let's use this texture instead. Let's go and watch what is going on here. To begin with, I'm just loading a simple yet small noise over here. And I can show you that these nodes are all linked. This is the albedo, this is the roughness, and this is the displacement. Everything is linked together. Same for this one, and I think there's nothing else. Or, oh yeah, same as this one. Well, and if you watch closely, there's just a couple of nodes which are changing. So what's going on here is just that the same texture is going to be going through a mix. So this is just the same with a different color. One being, one not a different color, but a different size. Pretty much the same color correction, not a different size. And if we go to the mix, it's like a mixture of two different textures here and there. How does this blend? It is blending because of this noise. And this noise is just a position with a multiply and a noise, nothing else, the same as the previous material. If you go further, we can see that we have another texture, that I want to bring, which is just a rock surface, and it's actually being blended by this ramp right here, which is just getting the normal of the geometry, separating on the Y and getting this definition here. It's just basically getting everything that's on this angle. It's like a mask. So if we blend both textures, it will look something like this. Now we have two things here. If we add a value, in this case a color, everything is going to be red. So we're going to be multiplying this by another value to make it even more reddish. And I'm going to be blending everything with another noise, which is basically the same idea here, but here multiplication of this mask by this texture, which is also being clamped a lot, which is giving us this. And when we put everything together, we're getting this texture, which looks quite nice. Well, the roughness are pretty much the same. It's just a matter of getting to know how roughness works. We're getting this roughness, we're multiplying with a remap, and also a little bit of noise here and there. So this is the actual roughness. I think this one could have been a little bit better, but I don't know. I ended up going for this one, which is pretty simple. As for the displacement, well, the trick is pretty much the same. We're getting a texture, we're multiplying it by height in this case, because I want to blend. I don't want to have a lot of displacement here to this kind of noise. I want this to be like the mountain side, and at the bottom we have the inversion, where we're going to be wanting a smaller noise for the rocks on the ground, and this texture also. Why is this so? Well, mainly, I remember all of these are remapped to match our needs, but it's mainly so we can control the different types of displacement at the same time. See that all the displacement are a little bit different, so we can control like the low resolution, I mean the low frequency, medium frequency, high frequency noises together. Everything is mixed with different textures, like for example this one, which is very nice. Everything is correlated. I mean, everything is correlated. Like the same thing is going on here is going on here, which is pretty much the same. And one final mix, which I believe a simple size F, which in this case is just not doing anything. Yeah, it's not. I think it's just remap. Yeah, this is the same as nothing, because it was, I could have done this and it's just the same. Don't worry about it. But yeah, everything goes into the displacement and everything looks nice after the day. And if I'm not mistaken, yes. Well, I have another one, which is the rocks. And the rocks, well, let me just show you. The rocks, which are these ones, they all have textures. They don't have displacement, but I could have used a displacement. But it was quite rough for the computer and it was, I think, worthless. But the rocks, which are this one, is just a simple texture with a multiplication of a color correct, nothing else but a specular roughness. Super easy. Well, everything is being applied like so. Everything is crystal is going to be crystal. On the mountain main is going to be the ground, and well, the instances of, I mean, the prototype of these instances are going to be the rocks. Previously on the rocks, I used to use the size F, where the smaller rocks would get less displacement and the big rocks would get much more. So this is all about the shading. A couple of things like adding a cool HDRI. Let's go to the camera. Let's just, for the time being, use what's needed here. So we have everything. I mean, now it is turned off. The crystals are turned off. So let me just real quick connect again the textures. There we should be going, I think. I set this to 1. There is no displacement on the ground, no displacement on the crystals. So this is how the crystal should be looking. Oh, I forgot to change the green light of the crystal, but it doesn't matter. So Well, the only thing I did is just basically have an HDRI or a simple field light, a ring light for well everything that has to do with. Let me just show you real quick with when the spaceship is coming, and a field top, which is just this one, which is on top of the ship. I think this is better to see before, like a couple of frames before the action. So here is what I was telling you about the field top. You can see it's filling the ship, and the rim one. The rim one here is just doing a basic rim on everything. The ground looks like this because of the lack of displacement, but you already saw the results. So this is how I usually go about the rendering. I usually phantom everything. Phantom everything means that the scene is going. Phantom everything means that the rocks, I mean, that everything is on the scene is going to be hidden. This is just a bug because it's just inside the scene. It should be clearly off. And as you can see, everything is pretty much empty because there's actually nothing. If we phantom everything, everything is going to be casting like secondary shadows, but there's nothing to be casted onto, so everything is going to be black. This is the first step. Secondly, I'm going to be dividing this into different layers. For example, the background. I'm going to prune everything but yeah, everything but the crystals at the back. Then I'm going to set a special displacement, in this case 1.5, the dicing, which is basically over a polygon per pixel. I'm going to set it to 0, otherwise this is going to explode. And I'm going to reveal these crystals. As you can see, these are the prototypes, because we always have to get the prototype for the displacement dicing, and this is just to rebuild them. We go here, we're going to be rebuilding them, and this is just a little more things to the karma render settings, which is more limits on the refraction, motion blur, but in this case we just don't need, there is nothing moving. This is path traced 256. I use CPU, but it could have been done with, and I'm having beauty divided into LPE tags, and also using reflection, glossy, indirect, glossy transmission, combined emission, position, depth, normals, crypto material for the crypto. So yeah, this is done for the comper, not for myself. He wanted to have these layers, so I gave them to them. Then I'm going to have another layer for the smoke, but firstly I'm going to be pruning. What I'm going to be pruning? The background, because I don't really need the background for anything. Then I'm going to be pruning the spaceship, because yeah, I just which I don't know why I'm pruning this. Oh yes, I'm pruning everything but the spaceship because I only need to render a couple of assets, which in this case is revealing the effects. And I need the spaceship to actually do the matte. As you can see, there is a matte going on here, which is the actual spaceship cutting over everything. Since this is a quick effect, I just did this with GPU. There we go. With GPU, well, I have a couple of settings set here, which is just motion blur, the settings, and the same things for everything else. Nothing different, just 32. I use, well, yeah, I use CPU at the end of the day. I don't know. I should have used XPU. Well, here we are pruning the crystals, and then here we are pruning the flames, because I used them here. I don't want them here. The first one is the cryptol. The cryptol is just everything mixed together, but just for the crypto. I'm going to show you real quick. As you can see there, one thing that I'm doing is just removing the volume and removing the lights. Just because I want to have the scene extremely empty and fast. I'm setting the motion blur, which there are easier ways to do this. If I were to do this again, I would have cached to use the camera and the assets properly for the next time. But yeah, that's what I use for the, well, I just copy some of these assets, like for example the ground icing, but I just reduce it to half, and the dicing of the crystals also reduce it by half, and I'm revealing everything basically. Yeah, I'm just revealing everything. And in this case, I'm just having very few parameters because all I need is the crypto material, the object, the depth, the normals, the position, and well, that's how it. Here is the same, but for the spaceship. Let's see how this looks. This is the spaceship with basically the motion blur on the dropship. Just well, basically on all the crystals, what I'm doing is the dicing set to 0. They are not revealed yet in this step. The dicing of the ground set to 0.2 because I don't need that much more. And finally revealing everything that's mid-ground, because which is the spaceship. I'm just revealing it, and the spaceship is just 256 samples, so not much. And these, in case you're wondering, I forgot, these are all just simple wraps. It's the same as use the render wrap, which is this one. It's exactly the same, but for my pipeline, which is based on Prism. In this case, the ground is, well, I'm just revealing the ground, dicing it to 1.1, increase that to 0.1 because I don't need much dicing there. I'm hiding the crystals, as you can see, and also hiding the rocks. This is the ground and rock is the sim. This is the simulation, hiding the simulation, because well, I don't need to show you. This is basically everything but the simulation, and the spaceship, and the volume, and the background. And in this case, the crystals. This is the background to beauty. The crystals are set to 1.5. The ground dicing 2.1 because this is the opposite of this. We don't need the ground in this case. I'm hiding it, so I'm basically everything but the primaries, and I'm hiding the rocks. But in this case, the opposite. I mean, no, both of them. I'm hiding both of them, both the simulation and the usual ones. And finally, for the volume, this is very interesting. I do not recommend this, but I had to do it. I'm dicing. No, this is dicing. Yeah, this I'm dicing the ground firstly, a little bit, not much. And remember, I haven't revealed anything yet. In this dicing, I mean, these are the instances of the rocks. I set this dicing to 0 because it was destroying my render times. The crystal dicing is at 2.2 because I don't need much more. I just need what's being used. And I'm revealing the volume, but also the simulation. Remember here, I didn't have the simulation where I'm going to have it here mixed with the volume. This is not ideal because you usually want to separate stuff, but it was either having issues with the holes in the smoke with the mate, or doing a deep compositing, which I didn't want. And basically I'm just using a mate over the ground, the crystal, and the environment and the spaceship. So I have only the volume, which I'm going to be showing. I have the volume with the rocks. As you can see, if we just disable the background, you can see that the spaceship is being matte here. We also have the rocks. Here is a motion blur of the rocks. And well, the ground is not visible here, but it's also being matte over. And this is all you need to know about this scene, at least in Houdini. So here we are, guys, with the Nuke file. This is the scene we will be recreating, and it all began from a black. The first thing we had to do is to actually get an HDRI of a cloudy scene, do some color corrections on top of it, turn everything into sphere. So this is the sphere that we have, looks quite nice. And then on a skyline render, we can see a part of the sky that we like. If we the rotation of this, we can then do a luma right here for an alpha, so we can increase the highlights of the cloud and then get a new grade on top of it. Then we can just do a crop. The idea of this crop is to keep this resolution and then just do a small defocus, as you can right here, to blur it a little bit. and then also crop again, so we don't waste render time. If we merge both of these things, we will only get the background. Then we will have our first render pass, which is basically this layer that I showed you before. I'm pre-multing this for the edges and then doing a shuffle of the pass that we want. As you can see, this is just a pass without the highlights, and we take a from. This way of merging is just to basically get everything but this AOB. We are going to be creating an alpha with the HSB tool in order to then use it for our for the glow. You can see we are doing a glow based on H's, then changing the saturation and then merging it again. You can see basically we are also getting a shuffle of the normals, selecting the green color and just this as a mask to create some more depth. Overall scene, adding a new grade right here to the overall composition, and then promoting this with the alpha. Also, we are doing, as you can see, a general C defocus here, based basically on bokeh. This is a bokeh that we got, and we have this spaceship where we are cropping. We are using an optical defocus. Basically, as you can see, it's creating the defocus based on where we want the target to be. So this is our main object we are focusing. Based on this, we're also copying on all of these. We're just getting the defocus here with the f-stops that we want based on, of course, our general defocus, which is this one right here. We're merging this. We're also merging this, which is the ground. The ground is similar. In this case, it's just a roto paint for some for some errors on the specific frames. These are the frames. We are doing another from to remove this AOB, doing some color correction on top of it. Let's go to another frame like this one, doing some color correction to make it less greenish like and make it more blue like. So this is what we're doing, and then we're merging everything with this defocus, the beauty, mid-ground beauty. As you can see, these are the rocks that we had from. We are merging everything with an over right here. Then of course another defocus to make everything more dynamic based on our original defocus, and we're merging everything. We're also merging everything here with the crystals, which these are the crystals that get deleted with a simple cryptomate, which looks something like this. So basically what we did here is to get the crystals here, then getting this AOB, removing it, doing a little glow, adding it back again, doing then blurring a little bit with the same trick of the normals, adding it, and then shuffling, I think is the blue light, yes, removing it and adding back again with a small color correction, multiplying it with the cryptomate. The cryptomate is basically everything but this stuff, and we're just removing it from the alpha. We are multiplying the mask with everything, so we're removing the also another focus, and we are adding it to the image right here. So there was an error with this defocus that, as you can see, without the multiplication of this depth to 1.56, I didn't get the results I quite desired. Basically, some of the values were wrong inside this depth. Then we are just cropping the extant pixels, adding it again. And right here, it looks like it's quite a lot, but in fact, it's just the spaceship, and all that I did right here is using every single one of these AOBs, which are the different lights that I showed you before, which is first get a blank one, get all of the AOBs. In this case, I'm pre-multing, changing the exposure. In this case, there's nothing. But then again, I'm doing this where if I want to show you, it's basically just doing an exposure change and multiplication of all. But in this case, again, nothing. But yes, I am reducing the noise with the reduce noise from need video. And all the color correction are done with Umbra mode and then Upper mode. This is the way to do it. This is the additive way of working, and this is the subtractive way of working. In the Rush, this was made with the subtractive, and now this is the usual method, where we are going to be adding layers upon layers upon layers, as you can see. So these are just some couple of changes to pop it up a little bit, adding more things to it, reduce noise again, with some exposure changes to make it everything desirable. Reduce noise again, and adding on top of it everything with some changes on lights and so on and so forth. There's pretty much nothing other than controlling a little bit of the lights. This potential stamp, the only thing I'm doing is getting back the alpha. As you can see, we were adding everything, but while adding this, I added the alpha, so it's all clamped, and with this, I'm just getting the usual alpha. And then I'm copying also the set, so it's not being, so it's being added correctly on top of it. Then I'm promoting again, doing a little more color correction on the ship, more color correction on top of it, and promoting again. So we are using the same alpha, and we are doing a luma on the alpha, promoting this. We are only getting these colors, doing an exponential glow and adding it back again with a plus, doing a motion blur when it's moving. This will add motion blur in some places where I cannot see right now. And then doing a defocus. But again, I think all the ship is, yeah, some of places right here are being defocused. Then cropping all the accents. So after we got everything here, this is the ship where we're going to have a defocus right here with the multiplication of the depth, adding a motion blur with the spaceship moving, and then doing an exponential glow on top of everything. We're meshing everything here, and we're copying the alpha. This alpha is quite interesting because we're going to be doing an edge blur for it. You can see on the alpha. This will merge the edges a little bit so they can be like diffused into the scene a little bit better. And we're going to do a shuffle right here to bring that to the RGB which I think is not needed. Then we have these thrusters where we are just grading it a little bit, as you can see, doing another exponential glow, but much stronger because this is the way everything works. We're adding the smoke on top of it with the defocus, again with another grade, as you can see, to blend it a little bit better over the image, and with a general blur on top of everything. It's just one size of pixel. Then we're adding a disturbance. What we're doing is having a noise, adding everything to the forward U and B, distorting it a little bit, and then dissolving everything again. This is always animated from certain part of the video, so it no longer works after the distortion. Then we're adding a little bit lens distortion on top of everything right here, adding some chromatic aberration and just a tiny bit, then dissolving an effect worked in logarithmic. This is done to basically have better colors. It changes the colors a little bit. As you can see, they're more like contrasted. It is always on half. We could go all in or all out. Those are the two ways. And an auto flare. The auto flare is quite nice. It's a really heavy effect, but this is what we are getting. These are tons of different sliders where you can work different looks And what I did is just to merge it on top of it with a really low mix. Then the vignette, this is a simple radial with a grade on top and a grade here, which is just a little bit of gain on the low side. Merging everything here will add this original grading effect over on top of it. This is like an overlay effect. Then we're doing a diffusion, so everything is diffused quite nicely. This is a self-made node, and on top of it some lens flares. I love these ones. But basically it's just a bunch of tools to change like the width of the lens flares working here. These are some also lens there that should have been revealed with a like blurring the beauty and multiplying it with this, so they are getting revealed, but in this case I just left it as they are. And I'm also adding some grain over here to make it more credible, and I'm cropping all the excedent pixels just in case, and then I'm just shuffling, I'm just writing this as with these settings. Hi guys, I hope that you enjoyed the full tutorial. Anyways, if you have any questions, please leave a comment down below, like, subscribe. See ya.